Well, hello there, and thank you for joining the November 2024 TAM Customer Webinar. The purpose of this webinar is to provide our customers the opportunity to hear from great speakers about content that will help them get the full benefit from their VMware by Broadcom software. Before we get into today's content, just a couple of basic announcements. First of all, our next TAM Customer Webinar will be on December 5th, and as you see on your screen, the topic of that will be Design Considerations with VCF Edge. So VCF Edge is an important topic, especially for our retail, manufacturing, and energy customers that have many small deployments of VCF. So be sure and watch for that invitation and get registered for that webinar. Your questions are an important part of this webinar, so please make use of the Q&A feature of Zoom to ask those questions. If there are any questions that we're not able to answer during this webinar, be sure and reach out to your TAM and ask them to follow up on your behalf. At the end of today's session, you'll be prompted to fill out a simple 2-question survey. Please take a minute to complete that, and which helps us understand how we can keep bringing you the content that you're interested in. And lastly, this webinar is being recorded, and your TAM can make the recording link available to you. After a few months, the recording goes publicly available on the VMware TAM Services YouTube channel, and so you can see it and all the past recordings for the past several years there. So this brings us to today's speaker and topic. So Pete Koehler is a coffee roaster, a storage guru, a familiar conference speaker and podcast guest, and is here to help us understand some of the key capabilities in the latest version of vSAN that make it a critical component of your private cloud. So Pete, over to you.
All right. Thank you very much, Andy, for the warm welcome. And hello and welcome, everybody, to this presentation where we're going to take a look at a little bit about what we've introduced recently within VMware vSAN, and in particular, the vSAN Express Storage Architecture. And really, not only what we've introduced, but where we're going with it. And that's with some of the recent announcements here around new capabilities, new functionality. You know, vSAN Express Storage Architecture isn't just about it being faster and more efficient. It's about introducing new capabilities to you. So I'm going to walk through what we've introduced recently, and then what will be coming, or at least a few of the capabilities that will be coming in VCF 9. Just as Andy mentioned, if you have any questions along the way, feel free to enter them in the Q&A, and we'll sort of work along. If you have anything along the way, I'll be more than happy to answer. So let's just kind of take a quick look at vSAN Express Storage Architecture and really why it is the ideal and the premier storage platform for VMware Cloud Foundation. Now, for those that aren't entirely familiar with the Express Storage Architecture, this was our revamped architecture that we introduced about 2 years ago, and it's our next generation architecture that was built specifically for high-speed storage devices, fast networking, computationally dense servers, and so forth. And that's really so that you can exploit the full capabilities of that hardware. Now, this is a sort of an optional or an alternative architecture to what we now refer to as the original storage architecture. That's the version that was known and that was introduced as vSAN just about a decade ago. Now, vSAN ESA is available really on any qualified hardware that is certified for vSAN ESA, and it really takes advantage of its capabilities by allowing us to then introduce new capabilities, new features, just unmatched performance and efficiency. It's really quite extraordinary. And because of that, we've seen a pretty significant adoption rate that we've had for the Express Storage Architecture. Because it sort of requires, just some higher minimum hardware requirements, we understood that would be a little bit of a long tail effect as far as you introducing it into your network, as you would have hardware refreshes sort of come up, and you would have to wait for that. But we've seen some really, really great adoption. Now, one of the capabilities, of course, of vSAN Express Storage Architecture is us to be able to provide storage as an exclusive resource of the cluster, so where we're aggregating these storage resources into the same host that the compute resources are at. And this aggregated approach is known as a vSAN HCI cluster. That's what we've always sort of known and promoted. But with ESA, we've been able to kind of extend this even further and provide the ability to disaggregate or separate the storage services from the client clusters that are providing the resources for the compute instances. So this allows you to run vSAN as sort of your centralized shared storage solution for your entire VMware Cloud Foundation environment, or just part of it. You can run them side by side. The great news is that regardless of what you choose, you're going to have this same experience as far as management and scalability is concerned. Just really trying to give the power of flexibility to you, our customers. Now let's take a look at what we've introduced here in the latest version of vSAN as a part of, it was vSAN 8 Update 3 as a part of VMware Cloud Foundation 5.2. And so we're not going to touch on every new feature, but these are really just going to be some of the highlights here. So the first step is introducing more flexibility as far as the topologies that we support within VMware Cloud Foundation. Now, vSAN Express Storage Architecture on its own has certainly supported the notion of a stretched cluster since its debut a few years back. But of course, you know, when we're running an entire full stack environment known as VMware Cloud Foundation, you have to have sort of other considerations come into play. And that's where, and we fully understood that we've had a lot of customers that have enjoyed and appreciated running vSAN in a stretched cluster arrangement. And so we've introduced support for this within VMware Cloud Foundation 5.2. Now it's not in the UI, the ability to set this. This is via API and CLI, but nonetheless, this is available now in 5.2. With the introduction of the sort of this disaggregated storage known initially as vSAN Max when we introduced that about a year ago, although just right on brand, we're making some changes on the naming. Just so you know, they're just going to be referred to as a vSAN storage cluster. But with the introduction of VMware Cloud Foundation 5.2, we can now provide this vSAN storage cluster or vSAN Max as principal storage within VMware Cloud Foundation. So that means this is something that when you're in the SDDC manager and you're rolling out a new workload domain, you can have the choice of, do you want this a vSAN, do you want this as an aggregated vSAN HCI arrangement, or do you want it as a disaggregated vSAN Max or a vSAN storage cluster environment? This kind of treats it now as that first class citizen. So if you are an organization that really loves their, you know, kind of that 3-tier architecture, but gee, you sort of like vSAN and you want to take advantage of all of that sort of free storage courtesy of your VCF licensing, this is a great option for you. You can have just centralized shared storage for your vSphere clusters that are in your workload domain. So really a nice option there. Now, we've had some questions initially about sort of this notion of a vSAN storage cluster or vSAN Max. And when it initially came out, you know, it was this opportunity for you to introduce a massive amount of storage capacity in an environment and using vSAN. Well, we've heard from a lot of our customers. They go, you know, this is really interesting. This is really great, but I don't need 7 petabytes of storage in my environment. I simply, you know, would like to see what this might look like as a replacement for my existing storage solutions. So we relaxed a lot of the minimum requirements for it. And you can start small with using a storage cluster. So let's look at what this actually looks like here. So let's imagine you just have an existing compute environment of your vSphere host, and it's a 3-tier architecture where you have your existing storage array. And you want to introduce vSAN Max or a vSAN storage cluster. You can start with as few as 4 hosts here. And so you build up this storage cluster. It has essentially a vSAN running on it, but it's going to provide a data store, and that data store is going to be mounted to your existing vSphere clusters. This is a way that you can introduce the storage services of vSAN in your arrangement. The compute instances of those VMs still reside on those vSphere clusters, but it's just mounting a data store like you would with any 3-tier storage. But there's a lot more, actually a lot more intelligence and control that you would have here. Now, if you, if at that point you say, okay, now I'm going to expand my compute environment, you can certainly do that and mount that very same data store. We decouple this notion of scaling compute and storage so that you can do it independently and sort of meet your needs. But let's imagine here for a moment that it's such a wild success that this small vSAN Max cluster is starting to run out of some room. Or maybe you want to make sure that you have sufficient performance. This is where the beauty of the architecture can really come into play, because at this point you can incrementally add the additional hosts in that vSAN Max cluster on an as-needed basis. And it's just going to still be seen as a single data store, so you don't have to, mess around with multiple data stores, LUNs, figuring zoning and masking and all of that nonsense. Is just going to provide that storage to all of the vSphere clusters. And the nice part about this too is that because it's at such a small level of granularity as far as the incremental nature of scaling out, then it's not as challenging to get some of those purchases through. If you had a case where in your 3-tier architecture, you were running into scenarios where this is a larger capital expense, it requires certain sign-off at some given management level and so forth. You can do this at a much smaller increment within vSAN. And then, of course, simply extend this capability on an as-needed basis. So just a really nice example of how you can grow incrementally here with vSAN Max. Now, the other misunderstanding that we had when we first introduced it, and this is 100% on us, is that when we would share information about networking requirements, someone might say, well, that's really interesting, but I heard you're requiring, 25 gig or 100 gig across the entire environment. And that's just not the case at all. So in this particular case, what you could do here is I show a rack that has some hosts that are for a vSAN storage cluster or vSAN Max cluster. And the top of rack switches here might be 25 gig or 100 gig switches. But all of your vSphere hosts that you have living across your data center and other racks can continue to use the 10 gig switching that you have for them. Now, obviously, it's always is nice to have faster networking when possible. But this allows you to introduce this as a storage option for your environment with very minimal uplift. I do have a question here. It looks like it come through. Is data replication over sites still done by the vSphere level, or is it in vSAN Max? So the replication, the synchronous replication across the sites will be done at the vSAN level. It was never done at vSphere, sort of higher up in the stack. So it's a construct of the storage system, and that's how we guarantee the synchronous writes across more than one location to ensure that the data is not only resilient, but it's consistent. So hopefully that answers your question. All right. So with that, let's kind of move off into the data protection side. And this was something that we have really introduced a lot of functionality that has had a lot of our customers, almost chomping at the bit as far as excitement is concerned. I do see another question. Mike Rock has, what is the protocol used for the compute clusters to connect to the storage clusters? Good question. It's not iSCSI. It's not NFS. It's not writing over something like Fiber Channel or anything like that. We use TCP over Ethernet as the actual transport. But on top of that, we use a protocol that we designed specifically for vSAN, known as RDT. And this is actually used in just an aggregated vSAN HCI cluster as well. And this is a extremely lightweight protocol that allows us to build up and tear down those sessions in a really fast way, as well as understanding where the data's at and so forth. That helped us avoid a lot of the technical debt from the things like iSCSI and NFS that predate um, so many of the common technologies that we're using now. There's a lot of artifacts from those protocols that we simply didn't want to inherit. Hopefully that answered your question. All right, so within vSAN Express Storage Architecture, we introduced a brand new snapshotting engine that is, think of it as it's very analogous to kind of those high performance snapshotting solutions that lived on a storage array. We eliminated this notion of a redo log-based approach that was common within vSphere snapshotting, and it was always a significant burden from a technical side in the way that it was writing data and updating data and so forth. So we introduced a brand new snapshotting engine within ESA that is analogous to a storage array, but it's actually a lot better. And I want to show you why. So here, when you look at something like a snapshot within a storage array, it's going to look at when you're taking a snapshot, it's going to look at the given LUN that has a data store living on top of it. And if you wanted to snapshot a certain VM, it has to stun that given VM and likely some of the others within that data store, and snapshot that entire data store just to capture that point in time for that given VM. Well, there's a lot of overhead in that, and there's a lot of administrative burden when you're trying to fetch that back into an environment. You have to go figure out which snapshot you want, mount it on, like a Bastion host, and making sure that you've disconnected in every possible way so that you don't see the duplicate UUIDs and so forth for the VMs. It was a tricky thing, especially if you wanted to really take advantage of those snapshots from a recovery standpoint. Well, vSAN ESA is different from a snapshotting perspective. Remember, we treat data with and manage data with a smaller boundary in comparison to a large VMFS volume. We look at things at what we refer to as an object level. So an object might be a VMDK, for example. Well, when we create a snapshot, it's just going to create a snapshot for that given object. So the metadata is just for that, and the management is just for those given objects. So you have a lot more agility there. And what's really interesting is because we have control of the entire I/O path, we don't have to stun the VM. That's a really interesting aspect. And so the functional result is really interactive, fast snapshots. We've virtually eliminated any notion of consolidation of those snapshots or the removal of those snapshots, which was historically always the big burden that we had there. So that, of course, that set the stage to introduce a new capability that we refer to as vSAN data protection. This is sort of our way to create an environment that you can use snapshots sort of in the way that you always envisioned. So we'll sort of step through that here. Before I do that, I just want to capture a few of the questions that we have online so far. So William says, in a vSAN world, are sites most commonly a logical construct within a single physical location or within a few miles of one another? Typically, when you're using a stretch cluster environment, you are defining a site as a physical, geographic location that is connected to the other site via some sort of inter-site link. And that is generally, 20, 30, 40 miles away, whatever the case may be, just falling within the latency minimums that we have in order to write the data synchronously. So that is typically what we see. We do have some environments, though, and some customers that have a large campus, and they're just running a stretch cluster from one site one part of the campus over to another. Now, is that going to protect you from a significant power outage, for example? Maybe not. It really just depends on your domains of failure that you sort of define and need to adhere to. So hopefully that answers your question. Let's see. Ray asks, you may be getting to it, but does vSAN data protection require any licensing outside of VCF licensing? Yes, I will most certainly get to that here in just a moment here. But if I don't, feel free to remind me again, because I want to make sure that we stay on time. So vSAN data protection is a mechanism that you're going to be able to really easily set protection outcomes that you want for given sets of VMs, and just set it and forget it. And vSAN data protection is going to manage those snapshots. So how frequent do you want to create the snapshots? How long do you want to retain the snapshots? Should the snapshots be fully immutable for, let's say, a ransomware protection, or should they not? That's going to set the stage for then being able to actually use those snapshots in a functional way, whether you are reverting an existing VM, for example, or let's say you have accidentally blown away a VM within your vCenter server inventory, which in the past, if you did that and you had snapshots, well, it blew away the snapshots too. You would have to use your backup solution in order to recover that. With vSAN data protection, you can recover that really easily, even if you've removed that VM from the inventory itself. And then finally, you can clone these snapshots in a way that can sort of support some of these workflows that you may have internally, where you are, let's say you have some SQL VMs, you have a development team doing some work, you can clone a given snapshot, spin that up so that they can use that as their sandbox for any future development and so forth. So really, really flexible. This ties in with our ability to provide ransomware protection as well for our VMware Live Recovery service as well. So a lot of functionality here, and we're going to step through actually with what this looks like within the UI and hopefully within a demo here for you. So you can, with regards to these snapshots, since they're kind of a set it and forget it thing, you typically want to know, how much capacity is occurring in this, or how much capacity is being consumed by snapshots, and which VMs are consuming that. All of this is available within the UI. So you're just using the same UI that you already know, the vSphere client, looking at vCenter server. It's all right there. And you have, whether you're looking at the cluster level or the VM level, or what a mechanism that we refer to as a protection group, which I'll explain that, you can see all of that. Now, speaking of our protection groups, this is a new construct within vSAN data protection that provides the ability for you to group VMs, one or more VMs, and assign it sort of the outcomes that you wish. So the frequency of the snapshots that they should be taken, the retention time, for example, how long do you want them to stay, and then whether or not you want them to be fully immutable or not. What's really interesting is that it supports an ability for dynamic association, and we're going to look through what this actually means here with this example. So here we have a protection group. Let's say that it's for your HR environment or something like that. And it's a very modest schedule. And for one reason or another, I've enabled immutability mode for these VMs, meaning that you just can't manually delete the snapshots. Now, let's say you have another protection group that is for your development VMs that include some front-end VMs as well as some SQL VMs and so forth. And then this is set at a much more frequent interval as far as the scheduling of them. But these are sort of static assignments as far as which VMs live there. Now, a third protection group is a dynamic association, meaning that in this case, I have it choose any VM and associate any VM that has the word SQL in it as far as the VM name. And that's going to run at a given interval. So this means that anytime, let's say in this case, you spawn up a few additional SQL VMs, it's automatically going to be protected. We don't have to worry about Joe, the junior IT admin, associating that, and protecting it in the way that the other SQL VMs are done. So it's a really nice mechanism for you to be able to sort of associate these VMs in a smart way. Now, we don't support tagging at this moment, but that is perhaps the number one most requested option, and we fully understand that that is a really important thing. Tagging in general, when we're talking about vSphere and vSAN, that's a broad topic. So we're working right now on the support of that. Now, as mentioned here, one of the capabilities here is its full support of being able to protect an environment against ransomware using our VMware Live recovery option. Now, we've of course have had VMware Live Recovery prior to the introduction of vSAN data protection, but we can take advantage of these really fast snapshots and the coordination between this independent or isolated recovery environment and the cluster that you're protecting. So, and in fact, when you spin up the VMware Live Recovery appliance, it's going to automatically detect when a cluster is using vSAN data protection and take care of all of the coordination, the communication between the two sites. Really a nice way for you to have, the combination of really fast scheduled snapshots on your primary site, but yet then have this level of protection for ransomware running in the cloud. So here's a case here where we have some VMs that were no longer in vCenter. They were blown away for one reason or another. We know it can happen, and it can happen easily. Happened to me years ago, all that stuff. But how do you recover? What does it look like? So in this particular case, what you would do is within vSAN data protection, there's going to be a tab showing removed VMs, meaning that VMs that used to be in vCenter server inventory but are no longer there. You simply highlight those given VMs and restore those VMs, and it will place them back using the associated storage policy and so forth. So really straightforward. From a cloning perspective, and I sort of touched on this just a few moments ago, this is where you can take an opportunity to use the snapshots that have already been taken to spin up instances of those VMs at the given point in time in which those snapshots were taken so that they can be used in other environments. We see this a lot with customers who have some sort of a dev test environment or they want to fence things off for these certain purposes. Now, remember, in any type of a cloning or link cloning, you'll want to make sure that this may be in a separated network or something like that so that you don't run interference there. Now we're going to jump off into a demonstration of vSAN data protection. But before we do that here, I do want to answer Ray's question more specifically. So the question is, does vSAN data protection require any licensing outside of the VCF licensing? vSAN data protection for local protection via those snapshotting mechanisms do not require any additional licensing beyond VCF. So it's just all part of the VCF license. We are introducing an ability for you to replicate or create those snapshots to a remote target, that remote on-premises target, whatever you wish to call it. That capability is going to be a part of the VMware Live Recovery add-on license. So you can have part of this vSAN data protection that's going to do local protection, but as soon as you get into areas where it's going to be remotely replicating those snapshots elsewhere, then it's going to be a part of the add-on. So let's see. Next question is from Thomas. Can you relay what the storage requirements for this new snapshot methodology entails? So from a storage perspective, you're going to build out your vSAN sort of your vSAN cluster in the very same way. If you plan on taking a large quantity of snapshots and you have a high change rate, that naturally means that you're going to be having an increase in capacity consumption. So you want to be mindful of that. Now you may go, well, how much more should how much more capacity should I design for? It really depends on the frequency of the snapshots and the change rate of your data, and only you know that. What I would really recommend is, to start out fairly conservative on the notion of snapshot frequencies, and then you can kind of adjust on an as-needed basis. This is actually the very same challenge that you run into in a storage array with the snapshotting mechanisms there as well. It's all about, the frequency and the change rate of the data. Now, we do have some mechanisms in place that we don't want you to get in trouble where you say, okay, I created an overly ambitious scheduling mechanism where you've created so many snapshots, you're going to run out of room. So at 80%, we are going to pause those snapshots so that you don't get in a situation where you're going to be running out of capacity. So just something for you to keep in mind there. Another question here. Let's see. Is vSAN data protection capable of performing application consistent backups for data stores? We don't support application consistency at this time. What I would really recommend or doing for that is just you need some pre and post pause scripting there. That will help meet some of those needs. And in particular, that helps you work around any notions of if you were using Microsoft VSS for any sort of application quiescing or file system quiescing. Let's see. Any features, how much space is needed with snapshot rate predicting when you run out of space? Yeah, just answered that. For immutable snapshots, is there a mechanism to call support to have them deleted? Yes, we will have a mechanism in place. There's a notion here there when it comes to immutability. It's like, okay, you want these things to be untouchable to prevent against bad actors sort of undermining you. But of course, there may be cases where you need to remove them or delete them. Then there will be mechanisms in place for GSS to support that. Now, if you have a retention schedule on those immutable snapshots, it's going to honor that. So if they're only going to be kept a certain amount of days or a certain frequency, then it will purge those out on an as needed basis. Let's see. Would the under development live recovery option be what you had mentioned at Explore would be performed as an asynchronous data write and not cause performance issues with workloads? Let's see. Yeah, so any sort of live recovery scenario is going to be asynchronous replication. So you're not going to be, the incoming writes are not going to be dependent on that. So you've decoupled this notion of performance from protection. Now, there are, with the kind of new instance of vSphere replication with a combination of this, we're going to support the 1 minute RPOs that drops it down from 5 minutes. That will help sort of in some of your requirements and your objectives there. But if you do need synchronous replication from 2 sites, that's going to be a stretch cluster, bottom line. Let's see, features like deduplication and compression available to conserve space. Yes, we will talk about that here in a few moments. And then what is the real world dedupe ratio? We're going to talk about that in a few moments as well. So let's take a look here at a demonstration of what this actually looks like here. And so here we have an environment where we have vSAN data protection configured. This is a data center with multiple clusters here. And there is a snapshot appliance that sort of manages the metadata around it, but it's not in the data path. And all of the snapshots are not dependent on that VM, meaning that the VM could be corrupt or be accidentally removed, and everything's going to remain. You'll be able to use the snapshots and so forth. It's just sort of a control plane mechanism. So here within the services, you're going to see Of course, this is for vSAN ESA, and then you're going to see a new tab known as vSAN Data Protection. And this is going to be that overview that I showed a little bit earlier here. And we're going to see things like the snapshot space usage and so forth. And this is where it's going to kick in certain thresholds. If you've run into cases where you're running low on capacity, it's going to pause those. Here we're going to look at the protection groups, and we're going to create a new protection group here. And in this particular case, you can choose immutability mode or not. We're just going to uncheck that in here. And here we're going to create or of the options here, we have dynamic individual VM selection, or or what we have for the query-based VM name selection. So here we're going to enter the pattern in which we want the VMs to be protected. So let's say whether they're all of the SQL VMs or all of your VDI VMs, whatever they may be, this is where you can take advantage of your naming taxonomy in your environment. We set the snapshotting schedule and the retention schedule fairly straightforward. You can set multiple schedules within a protection group. And this offers you sort of that, way to sunset out really short-term stuff, but keep things for an iteratively longer period of time. So now once we have that protection group created, you can see here that there's zero snapshots, and because nothing's been actually scheduled up yet. But we're just going to, in this particular case, take a snapshot just to sort of initiate this initial schedule. And by the way, this is a little quirk of it. Initially, you do have to take this initial snapshot. In an upcoming version, it'll just be at the next scheduled time. So from this point, it's just going to take a snapshot of all of those VMs. Again, extremely lightweight, no impact on performance, functionally no impact on performance. And now we can see the various VMs that are within there. Now, in this particular case, we're going to restore a VM. Now, restoring a VM requires that the VM be powered off if you are restoring a VM that's in place. And that makes sense, right? You wouldn't want to overwrite a VM that was active and running. So that's just good principles and hygiene as far as recovery scenarios. So we select the target, the location that we're going to. And again, this is protection, local protection. So we're recovering to the very same cluster that we were protecting here. And it's just going to recover that data and those VM instances. Again, the snapshotting engine itself is a part of ESA. We have a control plane that is managed through a virtual appliance. This is an independent virtual appliance, but it's actually going to be consolidated with things like vSphere replication and the old SRM or VMware Live Site Recovery. So it's just a single appliance running all of the services. So a nice way to sort of simplify that there. In here, we can see, the individual snapshots for, in a case, another VM that was protected under another protection group. And it's actually a part of 3 protection groups, so that you have a lot of flexibility just in that earlier version or earlier slide that I noticed. But one of the nice capabilities too is you can recover this via CLI as well. So it's not just within the UI. You can run through the Power CLI. William Lamb has some nice commandlets that sort of step through this process. So we sort of hijacked some of that here. But if you're looking to programmatically recover or clone or do whatever you need to support your internal workflows, you certainly have that option available. So this kind of gives a good overview of how vSAN data protection works in an environment. All right, so now let's jump over into a few things that we've done in terms of management, making things a little bit easier. Now, remember that within um, any sort of VCF environment that is powered by vSAN, you can run these vSAN clusters using vSAN ready nodes. And the ready node program sort of is these, predefined systems that have been certified and approved by the respective OEM vendors. And they can be formal ready nodes, or they can be what we refer to as emulated ready nodes. The formal ready nodes come across as a single SKU. You buy it as, hey, this is whatever given ready node shows up on your bill of materials as a single SKU. The emulated ready nodes are essentially from those same vendors, but they're just the individual components um, that reflect that very same ready node. So depending on your OEM vendors, sometimes from a availability or pricing, you may want to look at one way or the other. We wanted to make this clearer because sometimes customers were a little confused. They thought they needed to actually buy the ready node SKU, but you can actually buy the server and the componentry from that vendor that has it, just as long as it meets all of the approvals for the HCL. One of the interesting things that we've done within vSAN 8 Update 3 or VCF 5.2 is we're taking advantage of sort of the framework that we used for our lifecycle manager, VLCM. And we've built on and let our vendors build on a component to what we refer to as a hardware support manager. This is a module provided by each respective vendor, whether it be Lenovo, Dell, HPE, whatever the case may be. And what this does is this allows us to get some of the telemetry data from the servers themselves, in particular things like storage devices and so forth, so that we can better understand the condition of those components. So if you have a failing storage device or if you have an issue, we can surface this information, but in a normalized way. Remember, we're dealing with a dozen or more OEM servers, and they do things in different ways. This helps normalize the telemetry data that we get from them, so that you can, so that we can interpret it and transmit it and relay it in an easy way through a health check and so forth. Now, speaking of storage devices, we've made a lot of inroads here on monitoring sort of any impending failures of storage devices. In the past, the storage devices attempted to provide some intelligence there, usually through what was known as a SMART standard. But for SATA and SAS-based storage devices, it was not smart at all. In fact, it provided very meaningless data, and that's one of the reasons why we never used it, frankly, within vSAN. But under NVMe, there's a brand new open spec that provides really good and meaningful data about, let's say, things like the wear rate of the given storage device. So what we can do now is provide a monitoring of the wear rate of those storage devices, and when it reaches, let's say, 90% threshold of its expected warranted level of wear, then we can alert you, hey, this storage device is sort of ending its sort of warranted cycle of life. You may want to look at it. And we actually introduced this in vSAN 8 Update 2, but what we've done with vSAN 8 Update 3 is that you can set conditions on this, so that if you have different kinds of devices or from a different cluster, you can have different alarming thresholds for it. So this is a really nice feature, especially if you're concerned about, gee, are my read-intensive storage devices going to hold up in an environment? You don't have to worry or wonder anymore. It's going to provide you the information. Now, one of the things, when we think about it, it's like when you have a VCF environment, you can use all different kinds of storage. And many of you are using 3-tier architectures that have worked out very well over the past several years. One of the things we need to be mindful of, though, is that what occurs in a 3-tier architecture when in terms of storage. When you are sending, when a VM is issuing a write or fetching a read and so forth, as soon as those IOs leave the HBAs of the the actual hosts and then send them through the storage fabric to the storage array, you basically lose all of the intelligence of the priority of the kind of traffic, where it's coming from, where it's going to, and it sort of is treated like an equal citizen once it hits that storage fabric. Well, that becomes a challenge when you're trying to provide a very deterministic thing like storage. Well, within vSAN, whether it's a fully aggregated vSAN HCI arrangement or a disaggregated arrangement, we can see and control the entire IO path. So this gives us a tremendous opportunity here to not only provide better guarantees of the traffic itself as far as certain kinds of traffic having priority over another, but it also can provide much better visibility to what is occurring within an environment. And one great example of this is through something known as the vSAN VM IO trip analyzer. What this does is that it will look at the selected VMs that you wish, and you can run it for a period of, let's say, 5 minutes, 10 minutes, an hour, whatever the case may be. And it's going to tell you where the bottleneck is within the data path. This is incredibly valuable for scenarios where you're going, I have a mission critical SQL VM and it just doesn't seem to be behaving the way that I was expecting it. Well, remember, when we're writing data, we need to sprinkle it across more than one host in order to make it resilient. So if this can tell you, host number 7 has a NIC that it's flapping between 100 gig and 10 gig, that's a problem, and so this would be able to help surface that information for you. Really, really good. And this is the power of having essentially integrated storage built right in to the hypervisor. We own the entire stack, and we can see and manage and control the stack. And this is one of the sort of the prime advantages that you have as a customer here. One of the things when we talked about sort of a disaggregated arrangement, this is where we have a case of saying, okay, now we want to provide this visibility to, other management tools that you may have. So something like VCF operations. This is going to be a case here where now you can understand the topology of your arrangement, understand for this vSAN storage cluster, which servers or which vSphere clusters is it providing storage services for. Having a topology awareness there is a nice step in the right direction for monitoring your environment beyond just the cluster. Because we know that, obviously vCenter Server has always done so well when it has come to visibility of things, but it's generally at a cluster level, at a host level, and so forth. When it gets beyond the cluster, kind of the data center level, it doesn't have quite the visibility there. And so that's where something like VCF operations and paired with some of the new functionality here for understanding the awareness of the topology really plays in nicely. All right, so now we're going to look at where we're going. But before I do that, I want to cover some of the questions that we have here. So the features like dedupe and compression available to conserve space. Yes, I'm going to touch on that here in a few moments. And what is the real world dedupe ratio? Same thing. Going to touch on that here in a few moments. And then let's see, another question. Can a VM be protected by multiple protection groups? Yes. So you can have a VM associated with up to 3 protection groups. And then within those protection groups, the VM can have up to 200 snapshots per VM. So you have a lot of flexibility there. Yeah, so hopefully that answers your question. Let's see. Can we delegate restore operations through VCF automation? That's a good question. I think you should be able to, because we have a full API available for vSAN data protection. That's one of the huge differences that we had in the past versus other options and capabilities. So without knowing for sure, I'm presuming we will. Let's see. Next question is, if I understood correctly, vSAN data protection snapshots eliminate the disadvantages of previously snapshots. Yes, that is an absolute yes. So the old redo log based one where you're saying, I want to delete a snapshot, and you're just watching the bar slide across the UI, and you could wait for hours, and it's just awful. Yeah, all of that goes away entirely. So let's say a consolidation that used to take 100 seconds takes less than 1 second now. Huge difference. Let's see, and let's see. A part of that question is like, how many snapshots can negatively affect the performance of a virtual machine based off of how long the snapshot is in place? So there's no correlation between the amount of time that the snapshot is in place or the depth of the number of snapshots. The moment that you take an initial snapshot, you'll see low single digits impact. So let's say around 4%, something like that. But then whether you have one snapshot or 199 snapshots, it's going to be the same. So it's what we're essentially doing here is a series of metadata redirects. So it's all metadata based, and there's not that heavy lift of a redo log based approach that had to funnel through multiple trees in order to figure out where the updated blocks were. So hopefully that answers your question. All right, so we have a lot coming in VCF 9. I'm not going to talk about all of them today, but just want to sort of cover some of the key ones, and deduplication is going to be one of them. But we also do have some other cluster level and level enhancements and things like remote replication that I was mentioning before about vSAN data protection that we'll touch on here. Going to just focus on a couple of these though, because we just, for the sake of time, and I want to make sure too to give plenty of you the opportunity to ask some questions. This is what the presentation is for, is to be able to provide you the information, not just me ramble on for a long time. So, okay, so let's look at the introduction of deduplication for vSAN ESA clusters. This is going to be very different than any sort of deduplication that we had in the past for the original storage architecture. This is a cluster-wide deduplication mechanism, meaning that in the past, for the original storage architecture, it would look at a deduplication domain of a single disk group. So it would look at for duplicate blocks within the disk group and try to deduplicate that. Well, that's not a very broad dedupe domain. Here we're looking at the entire cluster. So if there's duplicate blocks within the cluster, we're going to deduplicate it. We use a very small level of granularity, 4K granularity. This is going to do two things. It's going to provide the optimal amount of deduplication, because the finer level of granularity, the more possibilities of duplicates. And there's going to be a more consistent amount of deduplication that occurs. Now, what you end up getting is really dependent on your actual data, your workloads. But internal testing has shown that if we, for example, do a clone of a VMDK 5 times, we get nearly a perfect deduplication on that, meaning that there's very little additional data to make sure that single instance of data is stored and referenceable to all of the other VMs. So that's a very good benefit here. The next step is that this runs asynchronously, meaning that it's geared to make sure that we don't interfere with the performance of the VMs. In the original storage architecture, it sort of did the deduplication as it was destaging the data and so forth. If you had heavy workloads, that would actually sort of impact the VMs. Here, this is going to be opportunistic and look for free CPU cycles and only perform the deduplication when there are free CPU cycles. And it's going to start with the cold data first. Basically, we use within the Express Storage architecture, we use a new log structured file system that gives us awareness of what data is hot and what data is essentially cold. And we work in reverse order with the deduplication. So we're going to dedupe the cold data first, because we wouldn't want to dedupe the hot data first, because that may be overwritten. Statistically, that's typically the way how working sets work, is you have frequent overwrites of the same data. So that wouldn't make much sense. So we really approach this in a smart way. It's fully integrated with all services, compression, encryption services, snapshots, and all various forms of data placement, whether it's erasure coding or mirroring. So let's actually look at how this works. Here's some sort of inside info, and this was something that I just built up for Explore last week. So if you weren't there, you most definitely haven't seen any of this before. So what we do here, and this is sort of the magic behind the deduplication that's coming in VCF 9 for vSAN, is that when we look at the write path itself, we're initially going to write the data in the very same way. We're going to compress the data, we're going to encrypt the data, and then we're going to issue the writes. Now there's checksums and other things that occur within that stack, but just for the sake of simplicity, that's what we're doing here. And that occurs up at the top of the stack, by the way. So when you have the data compressed and then it's sent across the network to make sure it's done in a redundant way, it's already compressed data. So it doesn't have to uncompress it or do anything silly like that. But once the data is residing there, then at a later time, the deduplication processes are going to look for the potential of deduplicated data. Now, it's initially going to create a couple of new objects within the data store. One is kind of responsible for holding the metadata hashes which is essentially us understanding which data is actually duplicates of each other. The next object is going to actually be responsible for storing the data itself, because we don't want to keep it with one VM or the other VM, because that would create hotspots. So we sort of move this if there's an opportunity to have data that is deduplicated. So we'll read the encrypted data. We're going to decrypt it using and then generate a SHA hash. This is a strong SHA hash, SHA 256. And then we're going to look to see if there's any duplicate data in that metadata object. If there are matches found, then it's going to update these metadata pointers and then kind of reclaim that space. If no data actually resides in the dedupe object, then it's going to sort of decrypt and move that object there and then update the metadata pointer so that things are pointing in that direction. This is all done transparently to the user. You don't need to worry about it. There's no dials for you to tune or anything like that. This is also meant to be scalable. So when I show, a couple of objects that are responsible for this, this actually spans out and scales out to add additional objects if that's what it needs for the cluster. So if you're growing a cluster, from 6 hosts up to 12 hosts or 18 hosts, whatever the case may be, we can grow with it here. So really an interesting way that we're achieving deduplication here. All right, so as mentioned earlier, with VCF 9, we are going to introduce the ability to have snapshots remotely replicated. So what we have right now is on the left-hand side, VCF 5.2 or vSAN 8 Update 3, local snapshots for local protection. Within VCF 9, we will be able to replicate these snapshots to a remote location. So think of something that, on premises that is managed by you that you can send these snapshots to. And the power behind this is that you can have your let's say your independent recovery environment or your isolated recovery environment for things like ransomware protection. You can have that sort of in this secure vault, so to speak, and have that data protected in an automated way. And then in the event that you have any sort of compromise or suspected compromise, you can spin them up, you run your analysis there, or you recover from there, whatever the case may be. This has generated some of the most interesting, sort of feedback from our customers, because they obviously realize the use case. This is using the snapshotting mechanism within vSAN ESA. So that's sort of the underpinning of it, meaning that the target location also needs to be vSAN as well. But remember, vSAN's included with your VCF licenses. So you're going to see the fact that you have entitled capacity that's available for use. So, hey, why not use it? So that's sort of one of the interesting scenarios that we've seen here. Again, whether it's for quick restores, DR, or ransomware protection, the choice is yours. You will be able to provide this ability to your environment. Now, this remote replication, of course, would require the VLR or the VMware Live Recovery add-on to support these sorts of use cases. So one of the scenarios that I touched on here is this notion of ransomware protection, and many of our customers, and in fact, we just getting back from Barcelona last week. You hear this all the time about saying, yeah, the cloud sounds nice, but we can't use it for a wide variety of reasons. So what do you have for on-premises solutions that will help me with protecting against my environment against ransomware? And this is where you can have VMware Live Recovery that can go to your fully owned site, and you can provide that a protective air gap mechanism in which you can have that isolated recovery environment, the IRE, and you have the tools in place to provide the analysis and the isolation for your environment, and any sort of failback that you may need for those given VMs. This is really, really important for so many customers, and if ransomware doesn't scare you, it should. So this is something that really helps address that scenario. Now, when we think about vSAN data protection, sometimes you can come across these cases of going, well, wait a minute, I've been using vSphere replication for a long time. How is this any different? And what should I think of when I'm evaluating one or the other? The capabilities for vSAN data protection will be using sort of a kind of a next generation version of vSphere replication. But what we can see here is some of the capabilities and the differences between the two or the three here. So on the left-hand side, we see vSAN data protection. On the far right-hand side, we see traditional kind of that vSphere replication that you may be familiar with. And then this enhanced vSphere replication, which was something that we were working along that was independent from vSAN. You can see a couple of interesting elements here. So one of them, of course, is the RPO is 1 minute. So that's really good and much more flexible than that 5-minute RPO that we saw in the past. The retention of snapshots per VM will be up to 200 versus vSphere replication was 24 essentially. And then the management of those VMs, of course, it uses the protection group construct. So from a scalability perspective, it's just going to be easier to manage. Within sort of the orchestration or interaction, you're looking at essentially just vCenter server. And then perhaps most importantly, from an API side of things, you have a full suite of API calls that will help provide the automation, the recovery, and so forth. Where we were really limited, it says no recovery API. It was very, very limited is maybe a more accurate way for us to say that there. So this is one of the differences here that we see. Okay, let me take a quick look here and see what we have for questions. By the way, I really appreciate all of the questions here. This either gives me a, I think a good understanding that you're seeing some interest in some of these areas. So keep them coming. Let's see, can we use vSAN Max with VVF or do we have to use VCF? Yeah, no, you can use vSAN Max or vSAN storage cluster using the VVF license. Your entitlement of storage is less, of course, at that case, but you can use a VVF license, no problem. When we think about vSAN HCI or vSAN Max or vSAN storage clusters, think of it just as a deployment option. Initially when we debuted it, it was actually going to be a different product, but then, licensing changed and all that sort of thing. Think of it just nothing more as a deployment option that, yeah, we do tweak a couple of settings on the back end as far as optimizations, but for the most part, it's the same product, but you're just not running VM instances on that cluster. So hopefully that replaces, or that answers the question. Greg asks, replacing SRM? Yeah, so let's hopefully clear some confusion about this. So Site Recovery Manager, or SRM, which was our orchestrated solution for kind of DR failover to another site, that falls under the umbrella of VMware Live Recovery now. It was sort of renamed. And don't throw any tomatoes at me. I'm not responsible for any of the naming. I'm just the messenger here. But it falls under VMware Live Recovery, and this is kind of an umbrella name that has a couple of different elements to it. So there is within VMware Live Recovery, there is the VMware Live Cyber Recovery, or VLCR, and that's this protect the data to the cloud so that you can have an independent, or an isolated recovery environment, and so forth. That used to be named VMware Cloud Disaster Recovery. Then there's another component of VLR known as VLSR. That's essentially SRM. So VMware Live Site Recovery falls under the VLR umbrella, and that is for the purpose of sort of the DR orchestration in the event of a disaster, some sort of failover, failback. They fall under the same product name umbrella, but right now they are two discrete, independent products. But that will sort of change as we go forward. But that's basically to help clarify, where's SRM, what's it called now, all of that sort of thing. So hopefully that was helpful there. Let's see. If you have a stretched vSAN or vSAN Max cluster, do you still require the remote license for backup and replication, considering it could be two physical sites, or is that considered a single site cluster? Now, okay, so good question, Kevin. Let's see if I can kind of pair through this and answer your question. When you have a stretched cluster where you have two sites, that is seen as a single cluster. So even though it's geographically separated, it's seen as a single cluster. So when you create a VM, it's going to store data in two locations. That there's no notion of a remote license or backup and replication license or anything like that. That's just a cluster that is living across two locations. So from a licensing perspective, you're going to license that cluster just as you would any other like single site cluster. That's so that's basically how that works. If you are running a case where you are running something like VMware Live Recovery, and that's at another isolated environment, you're doing asynchronous replication there, that is running VCF licenses as well. But there may be some adjustments, and that's something that I probably either can't or shouldn't speak on in terms of the licensing for that. So that may be similar, may be different. I really just can't be any more specific at that time. So hopefully that clears up that question. Let's see. David asks, in the live recovery portion that you're discussing in version 9, is that the advantage or is that the advanced part of the cloud only today, or is that the SRM portion of live recovery? That is the, so the part that I showed for vSAN data protection going to the cloud, that was referring to what used to be referred to as VMware Cloud Disaster Recovery, or VCDR. That's now called, it falls under the VMware Live umbrella or VMware Live Recovery umbrella, and it is called VMware Live Cyber Recovery or VLCR. So it's the very same solution. It's the very same mechanism. VLSR or the old SRM actually isn't supported with vSAN data protection quite yet. It's coming in VCF 9. So that's what we sort of have to look forward to there. And that was probably in the sort of the what's new list of a myriad of new features and capabilities within VCF 9, but I simply didn't have any time for it.
And Pete, we did have confirmation that no tomatoes would be thrown.
Perfect.
Yeah,
That's
so all is well there.
yeah. Well, very, very good. Well, I am going in to the office right after this, so yeah, maybe by proxy somebody's willing to throw one at me. Yeah. But yeah, so that's pretty much it. Hopefully this was of value to all of you. I really do appreciate it. And we do have, I think, a few more moments if you do have any questions. But I do want to thank everybody for attending. And again, if you found it helpful, great. If you maybe want to see some other areas, feel free to let Andy know, and maybe we can schedule up another one. Oh, good question here. Any ETA on VCF 9? Well, generally no. That's when it comes to announcement dates, a lot of companies are restricted by the SEC on when they can announce something versus release it. And so when you see the the messaging here, this is sort of VCF 9. It's not saying VCF 9.0. It's not saying VCF 9.8. It's a generalized approach. I would probably expect just our normal cadence of maybe first half of next year, but I would not hold me to that. Please don't. And I would expect maybe first half of next year sometime. All right. Let's see. And thank you very much, Kevin.
Yeah, echoing Kevin's words there for sure. Well, it looks like we got one more here.
Yeah. Let's see. Does VMware have any plans to support a 2-node hyperconverged failover cluster for smaller locations? The last I heard, it requires 4 nodes for failover protection. Yeah, you can absolutely have a 2-node cluster that would or could be a target location for any sort of data. So in that case, you would have 2 data nodes and then a third node that is acting as the witness host appliance that would help provide the quorum in the event that there was a failure of one host versus another. 2-node is an incredibly useful scenario and one that any opportunity I get, I would encourage, and interestingly enough, you can make a 2-node cluster incredibly fast and incredibly resilient based off of some newer, more interesting mechanisms that we have for failing over in that sort of arrangement. Let's see. John mentions or asks, are there any performance benchmarks available for comparing ESA versus OSA? Yeah, we have a number of partners who have done large number of performance comparisons. You can find them out there. Intel, Dell, and others. I think Lenovo and maybe somebody else has done performance benchmarks, and those were oftentimes done on the initial GA release of ESA, which we've had some pretty dramatic performance improvements from there. We typically see between 2 and 5 times the performance increase for using the very same hardware. This is not an increase in hardware. This is running sort of apples for apples comparisons. Then we see space efficiency improvements of about 60% versus OSA because we can always run RAID 5, RAID 6 erasure coding. So you're guaranteed a much more space efficient data placement for when you're storing resilient data. And then our compression mechanism within vSAN ESA is much more efficient. So instead of getting, let's say, 1.2x for compression ratios within vSAN OSA. We're getting 1.6, 1.7x with 30% of our customers getting well over 1.7x. One of our A-host lab clusters was getting 2.1x, and that was just with compression only. So really good there. Let's see. David asks, historically, vSAN vSphere dropped at the same time. vCenter 7 update 3 was the same date for both. We have seen the vCenter releases a week or two before vSAN. That's a good question. I don't know. Yeah, that's our release train has been a little bit different. In recent years, we've had to kind of factor in some of our cloud providers as well. So there's some areas there, but for the actual reason why, yeah, I'm not entirely sure. Let's see. In your opinion, what is the ideal amount of ESXi hosts in a vSAN cluster? Yeah. You know what? What I really like, I see a lot of customer environments. If you're a large enough environment, let's say maybe you have anywhere from 10 to 12 hosts, that's really nice. And that's for a couple of reasons. You have plenty of room to support a failure to tolerate of 2, which requires 6 hosts. So all of your VMs can run in a really space efficient way. And a 12 host cluster can easily fit within a single rack. So that means that you can keep the vSAN traffic within the top of rack switches and not traverse the spine. And generally we see, and maybe some of you may have your own thoughts here. When you get up to about 16 hosts, it gets more difficult to fit that number of 2U servers within a rack. And so then you're spanning multiple racks, and then you're traversing the intra-cluster vSAN traffic across the spine. And if that spine is oversubscribed, then you may run into some performance issues there. So hopefully that answers that question. Let's see, in a HCI vSAN environment, upgrade of compute and vSAN goes together with vSAN Max, can you have perhaps a different version? Absolutely. Yes, you can. And that's one of the nice benefits here. You don't have to update them at the same time. So if you have a more conservative approach on your storage than you do your hosts, that's fine. Now, if we're introducing some new capabilities, there may be some new dependencies there, but for the most part, you can take a strategy of saying, hey, you know what, this is my storage. I'm going to take a little bit more conservative approach on this, and then have a little bit more of a 0-day update on your vSphere hosts. Let's see. It says, next question is, am I understanding correctly that this new snapshot architecture can't be used with the existing storage appliances? Let's see, I'm not quite sure what you're referring to as storage appliances, but the snapshotting architecture that I described here is an exclusive part of the vSAN Express storage architecture, and it's built into the actual storage stack. There are no appliances that create it in any sort of way. The one appliance that I was referring to there in terms of vSAN data protection, that's just, think of that as just kind of a control plane that helps render some of the information about snapshot usage and protection groups and things like that. It's not a part of the data path, and it's nothing like that. And this capability will never be ported back to the original storage architecture. We're just fundamentally different from there. And if you are thinking about anything regarding OSA, only keep it for existing clusters. Don't even think about it for a new cluster. All of our development is on ESA and has been for the last 2 years.
Yeah, and I think he's clarifying there, Pete, that just the underlying vSphere snapshot technology, right?
Oh, yeah. Okay, great. No, thanks for the clarity there, Andrew. The snapshotting mechanism for a traditional storage arrays remains the same. So that's going to be a VMFS-based redo log approach. So you're going to see the same behaviors if you have some vSphere clusters using a data store that resides on a storage array. That what we are discussing here is exclusively vSAN. Let's see, is the IO Analyzer a vCenter plugin or a vRops construct? No, it's just built right into vSAN itself. So within vCenter Server, you can go into the cluster level, and you're going to see it as one of the items in the list where you see, for vSAN options. It's a great tool. It really is. We've used it internally for some troubleshooting as well. And any other questions?
Yeah, it looks like we've about reached the bottom here. So,
Yeah.
Pete, thanks so much for
Mhm.
just being really generous with your time and knowledge, and you provided just great content for everybody today. It's clear from the responses, so we really thank you for that. And it's really exciting to see all the advancements in vSAN, just how it continues to grow and become this critical component of VCF. Um, as was mentioned at the beginning, this presentation was recorded, and your TAM will make that recording available to you. And we do hope you'll join us next month. That'll be on December 5th, when the webinar will be covering the topic of VMware Cloud Foundation Edge. So hopefully any questions you have, we can get answered at that time. And have a great rest of your day. Thanks all for joining in.
Yes. Thank you, everyone.